Hi, welcome back to our topic of today. So we shall be discussing on electrostatics 2. Electrostatics 2 is a second topic after electrostatics 1, which mostly is applied at Form 3 level, Form 4 level, or above the O level. Using this example, we have the question. So the circuit below shows network of capacitors connected to a 24-volt supply. So you have here a 6 microfarad capacitor, a 4 microfarad capacitor, a 5 microfarad capacitor that are in parallel. Then you have here a 3 ohm microfarad capacitor, then a 7 microfarad capacitor that are in series. So from the question, we want to determine the voltage across this 5 microfarad capacitor, the voltage across the 3 ohm microfarad capacitor, which is in series, then lastly, the ammeter reading or the current that is passing through the 7 ohm microfarad capacitor. So the first question here is to determine the effective capacitance. So we want to see how do you find the total capacitance across a circuit, or in other words, the effective capacitance. So from the space here, we can come and say that the effective capacitance is given by the capacitance in parallel plus the capacitance in series. So starting with the capacitance in parallel, capacitance in parallel. So it's given by, so you can see have here a 6 microfarad, a 4 microfarad, and 5 microfarad that are in parallel. So you normally add them directly. So we now have our 6 plus 4 plus 5, which gives us 15 microfarad capacitors. Then from there, to determine the one in series, you shall write that in series capacitance will be given by, so the series one, you have these two, you have 3 microfarad and 7 microfarad. So it comes out to be 1 over 3 plus 1 over 7. And because they are in series, we find the inverse, which gives us 2.1 microfarad. But remember, the effective capacitance will be given by the total in series, which is 1 over 2 plus 1 over 15. Then you find the inverse, which gives us a total or effective capacitance of 1.84211 microfarad. Remember, we are adding this one because it is also the one in parallel. And remember, from the diagram, the effective capacitance in parallel is in series with the capacitors in series. So therefore, the final answer becomes 1.84211 times 10 raised to negative 6 to change to SI unit Faradays now. So from there, we are through the first question. So our second question here is to determine the total charge. So we want to see how do you find the total charge. So from the space here again, you can see total charge is given by, from Q is equals to CV, total charge Q total is equals to C total, which is the total capacitance, times V total, which is the total voltage. So it comes out to be, our total capacitance here is 1.84211 times 10 raised to negative 6, then times total voltage from the circuit. We have a voltage of 24 volts. So times 24 times 24, which gives us our effective charge or total charge of 4.4211 times 10 raised to negative 5 coulombs. Then our third question is to determine the charge through the 3 microfarad capacitor and then 4 microfarad capacitor. Remember, the 3 microfarad capacitor is in series, then the 4 one is among the ones in parallel. So how do you find the charge through the 3 microfarad capacitor? So you say here that charge for 3 microfarad capacitor, because it's in series, charge is the same. So charge in series is the same as the effective charge or total charge, which we have calculated and found it here to be 4.4211 times 10 raised to negative 5 coulombs. So we move on to our second part, which is to find the charge in 4 microfarad capacitor. Remember, 4 microfarad capacitor is here among the ones in parallel. So we normally say that charge is distributed according to the ratio of the capacitances. So therefore, it will be 4 over the total capacitance, which is 4. You have here 6, 4, and 5. And because they are in parallel, the effective capacitance was 15. So it comes out to be 4 over 15 times 4.4211, which is the total charge, times 10 raised to negative 5, and that one leads to our answer here as 1.17 times 10 raised to negative 5 coulombs. So then from there we can say that the second last question is to find the voltage through the 5 microfarad capacitor and 3 microfarad capacitor. Remember, the 5 is among the ones in parallel, then the 3 is among the ones in series. So how do you go? So to find voltage across the 5 microfarad and 3 microfarad capacitor, so you come and analyze and find that the 3 microfarad is in series with the circuit. Remember, in series, charge is the same as the total charge. So you come and start by the 3 microfarad capacitor. So where you say that the charge there is the effective charge. So charge, you had found the effective charge or total charge to be 4.4211 times 10 raised to negative 5 coulombs. So therefore, voltage is given as charge of a capacitance. So it comes out to be 4.4211 times 10 raised to negative 5 divided by the capacitance of the 3, which is 3 times 10 raised to negative 6, and that leaves us with 14.737 volts from the calculator. Then for 5 microfarad capacitor, so we come here and analyze that in parallel, the charge distribution here depends on the ratio of the capacitor. So it's normally directly proportional. Therefore, the 5 microfarad would be 5 divided by the total, which is 6 plus 4 plus 5, which becomes the charge there is equals to 5 over total, which is 15, times total charge, which is 4.4211 times 10 raised to negative 5. And that one from the calculator gives us 1.4737 times 10 raised to negative 5 coulombs. Therefore, the voltage now becomes from charge over capacitance, it becomes out to be 1.4737 times 10 raised to negative 5, then divided by the capacitance of the 5 ohm, which is 5 times 10 raised to negative 6, and that leaves us with 2.9494 from the calculator, 9474 voltage. In the same way, we can also say that because these are in parallel, the voltage in parallel is normally the same, so that we find the total voltage here supplied minus the voltage in series here. So therefore, voltage in parallel is equals to total voltage minus series voltage. So series voltage will be given by, so the effective capacitance here, and remember in series charge is the same as the effective or total charge. So we take it to be total charge, which is 4.4211 times 10 raised to negative 5 divided by the effective capacitance here. So we had found this one plus this one inverse, so gives us 2.1 times 10 raised to negative 6. So that one leaves us with an answer of 21.0528 voltage, if I'm not wrong. So from there is the voltage in series. So therefore, in parallel, it becomes total voltage here, which is 24. So 24 minus 21.0528, which gives us 2.9474 voltage. So therefore, you can see that this one and this one are the same. So you can choose to use this method here of finding the charge in the 5. Then from there, using that charge with the capacitance to find the voltage for the parallel one, or using this issue of voltage in parallel is equals to total voltage minus the series voltage, so that you come and find the voltage in series Then from there, come and subtract from the total voltage to get the voltage in parallel. So it's you to choose the best method. Back to the question, we are now to find the energy stored in the 3 microfarad and 5 microfarad capacitor. So 3 microfarad capacitor, energy stored is given by a general formula of a half times capacitance times voltage squared, so that for 3 microfarad capacitor, the voltage you have calculated and found that the voltage there from this previous working, the voltage was 14.737 volts. So we come and take it to be 14.737 volts, so that we now come out and say that energy will be given as energy is equals to a half times capacitance, which is 3 times 10 raised to negative 6, then times the voltage squared, which is 14.737 squared. Then that one from the calculator leaves us with an answer of 3.258 times 10 raised to negative 4 joules. So for 5 microfarad, it gives us the voltage also supplied. We are using the voltage in parallel, which is found it to be 2.9474. So you come and see that it implies a voltage of 2.9474 volts. So you're replacing the formula, energy is equals to a half times capacitance times voltage squared. So it becomes a half times the capacitance is 5 times 10 raised to negative 6 times bracket 2.9474 squared, giving us an energy of 2.172 times 10 raised to negative 5 joules. So we can therefore ask ourselves that between parallels and series connection, which one stores more energy? And also, remember the last question here is to find a simple way of calculating the total energy stored in the circuit. I wish you a nice time. If you have a question, you can post so that we solve together. Thank you.